Welcome to Sustainability Matters. I'm Tria Case. Today's topic is the grid. Con Edison provides electric service to New York City and Westchester County. That's power to millions of customers. They do this through multiple substations and thousands of miles of underground cables. People just want to flip a switch, and they assume that the power will be there. However, the demand for electric power is increasing, from the simplest need to charging our cell phones to life-saving equipment used in our hospitals. Just like with our cars, our phones, our computers, we want it better, faster, and cleaner. Today, we'll discuss how New York City grid is becoming smarter, more efficient, relying on green and renewable resources, and becoming resilient. Let's get started with an overview of how the grid is designed and how it works with a report from Ari Goldberg.
The U.S. power grid is often considered the largest machine in the entire world. With 3 interconnections comprising over 600,000 miles of transmission lines, 5.5 million miles of local distribution lines, over 2,200 utilities, 900 rural electric cooperatives, and 7 regional transmission organizations and independent system operators. In short, it is complicated. But of course, the grid wasn't always that complex. The world's first was here in Manhattan in 1882. Thomas Edison's Pearl Street Station, initially powering 1 square mile and 59 customers. Nowadays, about 90% of the world's population has electricity access, and the basics of how grids work around the globe are pretty similar. In a nutshell, first, of course, power is generated. Maybe that's a wind farm, maybe a coal plant. It gets sent along massive, high-voltage transmission lines towards its target area, where a local substation then routes it towards buildings and homes along lower voltage power lines. Along the way, a series of substations, transformers, and regulator banks can manage the voltage so that what finally enters your home's meter is the common household 240 volts. Now, all of these points in the grid need monitoring, maintaining, and upgrading to keep the power on. For places like NYC, much of this infrastructure is underground, making upkeep more difficult. One of the reasons Con Ed customers pay some of the nation's highest electricity bills. And indeed, upkeep is long overdue across the US, with infrastructure decades old in many sectors, frequently older than its intended lifespan. For a local example, NYSO, the New York Independent System Operator, which manages the state's grid, estimated that about 5,000 miles of our transmission lines would need replacing in the next 30 years. But despite the needs, the federal government has spent less on infrastructure over the last decades, hovering around 2.5% of GDP. For comparison, Europe averages around 5%, and China 8%. And as an aging grid deals with increased energy demands, plus strains from climate change, power outages in the last 6 years have more than doubled since the 6 years prior. Even vital efforts to fight climate change can strain it. It's one thing to connect power lines to a coal plant you can build near a city. It's another thing to connect renewables, say a hydroelectric dam, which might be hundreds of miles away. But the construction of these essential transmission lines is one of the major bottlenecks to adding renewable power to our grid, needing project clearance not just from the Federal Energy Regulatory Commission, but also state, local, and sometimes even individual landowner approvals. By 2021, there were more than 8,100 energy projects waiting for regulatory permission to connect to our grid across America. According to a government study, less than 20% of solar and wind proposals survive what can be years or decades of waiting, often a more cumbersome system than other countries. But there have been efforts to make the process easier. The Infrastructure Investment and Jobs Act of 2021 contained $73 billion for green energy transmission, and $20 billion coming specifically through the Building a Better Grid initiative. The other side of the coin, of course, is improving technology for the grid we already have. For instance, implementing a smart grid with sensors monitoring our power lines' loads in real time to maximize their carrying capacities. In fact, the largest of these dynamic line rating projects in the country is in upstate New York, Indeed, the Biden administration has called a modernized grid the linchpin of the green energy agenda. Because from Edison's first station in 1882 to Consolidated Edison's now 62 substations, we'd sure like to keep all of them powering New York and a sustainable energy future. For Sustainability Matters, I'm Ari Goldberg.
And now, before we speak with our colleague from Con Edison, we welcome Ahmed Mohammed. He's an associate professor of electrical engineering at City College. And he's the director of the CUNY Smart Grid Interdependency Laboratory. Welcome, Ahmed.
Thank you, Trey.
Thanks for coming in.
My pleasure.
So, can you talk to us a little bit about the Smart Grid Lab and what you're working on?
The Smart Grid Lab is a research facility located at the City College. We founded it in 2013, and since then my research group and I have worked on multiple research projects in close partnership with either the industry or federal and government agencies. These projects collectively aim at making the grid more resilient and decarbonized. Another thing we work on is to help prepare the next generation of power engineers through these research projects and project-based courses that I teach at City College. We realize that the power grid is evolving and the power engineering curriculum must evolve as well and transcend the boundaries of classical curricula with the emerging technologies like artificial intelligence, digital twins, and so on and so forth. So we're updating the curriculum. Another thing that we're working on now is to expand on the power program, and our goal is to make City College the major pipeline for power engineers of the future.
How is the work at the lab helping us to, really make the grid smarter?
Our research is divided between applied research, where we help our partners, usually companies or like Con Edison, or agencies like NYSERDA, APRI, MTA, answer some questions. The other type of research that we also do is basic or fundamental research. So in applied research, we lean on our understanding of power grid fundamentals. We typically build high fidelity models that we could use to answer some questions. For example, we all know the goals to decarbonize the grid. But if you look at these goals through the lens of distribution network constraints, will they really be feasible without costly upgrades? So we work, for example, with Con Ed to model the grid under futuristic scenarios of high impact of high penetration of renewable, more electric vehicle chargers, and so on and so forth. In another example, we have been working closely with Con Ed, the MTA and NYSERDA, on improving the energy efficiency of the subway system. So it's work that we have been doing for years. We explore ways to incorporate the regenerative braking energy that the trains produce every time they stop. And based on the work we did, some demonstration projects are currently underway, supported by NYSERDA, and we're still heavily involved in that. The subway system is a complex system. Each train car is a power system by itself, and there are the third rails carrying the power coming from substations, rectifier substations, which are connected to Con Ed network, a very complex system. If we're able to build a model that can capture all these complexities, it's priceless, because before these stakeholders make large investment decisions, they can determine the best place to put the energy storage, the optimal size, optimal charging, discharging mechanism, and so on and so forth. So these are some examples of the applied research we do. In more fundamental research, we come up with the questions, and we oftentimes are less certain on whether we will be able to solve them or not. So in one of my projects with the National Science Foundation, we're trying to develop models to help us better understand the interdependency between the power grid and other infrastructures. Like, think of what will happen in the next big failure when we rely more and more on electric vehicles. Electric vehicles will need electricity to charge. Charging behavior of the people will affect the power grid. So this very complex problem require like new sciences usually. So this is another example of basic research that we do.
And when we make the grid smarter, how do we make sure that we're protecting the grid from external issues that might come our way now that we're relying on sort of more distributed power, for example?
I think it's a very valid concern. Smart grid entails heavy reliance on telecommunications, which come with vulnerabilities. And before DERs, before distributed energy resources and renewable energy, the power was almost exclusively produced in central power plants and delivered via the utility, where you have skilled workforce, you have the funding, the financial ability to have sophisticated software and hardware and strict standards to follow. But when resources become customer-sited, then obviously they will be less sophisticated and you have more vulnerabilities. In my view, we have to do some early standardization, and new controllers must have features to detect cyber attacks. And here I don't look at for some people, this might look like a cyber security problem. Cybersecurity measures are very important, like encryption, authentication, all of that. But I encourage my fellow power engineers and researchers to heavily contribute to solving this problem, because I feel like it's a hardcore power problem to me. If I look at a power network, if I measure a voltage of 1 per unit somewhere, X, call it X, and the same voltage in an adjacent node, if the third node, the sensor is consistently telling me the voltage is 0, very different. By the laws of physics, it's impossible. And a power engineer can only tell that. So we need to embed this kind of intelligence into the controllers and not wait for the telecommunication layer to tell us.
Is that sort of AI in a way?
Of course, a detection method would rely heavily, I think, on artificial intelligence and digital twin. When something comes in, if I have a very good model for the system, I can easily tell whether it makes sense or not.
So how do you involve your students in doing this kind of research?
So all these research projects we do eventually go down to postdoctors and PhD students and master's students and undergraduate research assistants. So we try to involve researchers at all levels and layers. And once we're done with this research, and history tells, for my group, I've been around for 10 years, students work on a project, let's say with IPRI, usually they get hired by IPRI. Con Edison, they get hired by Con Edison, and so on and so on.
The hands-on applied research really makes a big difference for everyone. Well, that is sadly all the time we have at the moment, and I just thank you so much for coming in and for all the work that you're doing in the lab and at City College. Thanks so much.
Thank you, Treya, my pleasure.
So now let's go to White Plains and a visit dedicated to team members at NYPA's Integrated Smart Operations Center. NYPA stands for the New York Power Authority, and they're a major electricity provider in New York State. It's been actively working to upgrade our grid for increasing the flow of renewable energy. Mary-Eve Ami visited their Integrated Smart Operations Center, the ISOC, a key entity in this endeavor. And we've got a City College graduate working there, so let's take a look.
Here, we're looking at various facilities across New York State. Up on top are hydro generation units. We have BG, which is in Limeham-Gilboa generator, which is in central New York. Niagara Power Project, which is in western New York. And St. Lawrence FDR Power Project, which is in northern New York. And essentially what we're monitoring here are water levels and gross megawatt output of what our hydro facilities are currently doing.
Jimmy Delvados is a senior monitoring and diagnostic engineer at NYPA's Integrated Smart Operations Center. When pursuing his education and career, he was always interested in the power utility industry, and most specifically, in innovative solutions to make the power grid more sustainable. As an operator at the ISOC, he is doing just that.
When the ISOC began back in 2018, there was a sensor deployment initiative to be able to maintain a reliability of our system, of our grid, and maintain power generation to our customers. So we're primarily focused on asset reliability, cybersecurity, network operations, and physical security. Essentially what we're doing is we're utilizing machine learning techniques to be able to develop models of how our power plants should be operated and we are able to communicate and report with the site, the power plant operators, what sort of instrumentation or sensor issues we may have identified here in the ISOC.
The ISOC is also a crucial tool to predict the health and best use of transmission lines, and as well to respond to potential emergencies that could cause power outages.
So this screen up here, this is our Y49 underground undersea cable. This cable runs from Springbrook, I would say Westchester area of New York, all the way down to Long Island. And what we're monitoring here is if there's any ships within the surrounding area and they drop any anchors, this would notify us if they were to strike our cable.
The New York Power Authority is the nation's largest state-owned power organization and owns a third of the high-voltage assets in New York State. It has set ambitious targets to reduce carbon emissions from its operations and promote renewable energy.
It's a very exciting time to be in the utility business in New York State. In the last several years, there has been more transmission under development and construction than I would say in probably the previous 30 years combined. One of the main challenges in the transmission system in New York is congestion. So as the power is generated primarily upstate and the main load is down in the New York City area, the transmission lines become overloaded and you cannot push more power across those transmission lines. So a lot of these projects are being constructed to relieve that congestion.
NYPA is not only investing in upgrading transmission lines, but also expanding its renewable energy portfolio, demonstrating its commitment to a sustainable and resilient power system.
In 2019, New York State passed the Climate Leadership and Community Protection Act, which sets very aggressive goals for renewable generation in the state of New York. Clean Path New York project includes the transmission line from Fraser to New York City area, as well as a renewable portfolio of wind and solar being developed by Energy Re and Invenergy of over 3,000 megawatts of new renewable generation in the New York State system. So that additional renewable generation upstate transmitted across the transmission line will help relieve the fossil generation in the New York City area and displace that generation.
For Sustainability Matters, I'm Maria Vami.
We now welcome Steve Wemple, the General Manager of Con Edison's Utility of the Future team. Steve, welcome. Thank you for coming.
Thank you, Tria, for having me here today.
We heard earlier about how the grid works, but can you give us a sense of what the utility of the future is and what you're working on?
Well, that's a great question. Utility of the future, I'd call it an evolving thing because utilities have been around for a long time. As you may know, Con Edison celebrated its 200th anniversary delivering energy to customers this year. We started off with natural gas and steam and moved into electricity. With Utility of the Future, we realize, though, that we can't just rest on delivering electricity. We have to be a partner to our customers, helping them both reduce the amount of energy they use and help them decarbonize the energy that they do use. The combination of those two are going to be key to getting to the state's clean energy goals.
So what are some of the challenges or projects that you're taking on in order to make that happen?
One of the big challenges we face is getting the right infrastructure out there for our customers to use, in particular for electric vehicles. We currently have about 5,800 electric vehicle chargers throughout New York City and Westchester, but we have a goal to get to 18,000 by the end of 2025. And that takes a lot of forethought on both our part and our customers' part. So we have to work with customers at the planning stage when they're thinking of putting in these charging stations. Many of these charging stations can use as much power as a large office building, but they can be built in a matter of months. So historically, we had years as we watched customers build up their buildings. We knew we had lead time to plan the infrastructure to keep up with them. And now we're working with them on a much shorter time frame. So that creates new challenges both for us and expectations on the customer part. Why can't we be ready sooner?
You know, if we think about that in the context of distributed generation too and renewables, are there efforts or projects that you're working on that sort of parallel that as well?
Well, certainly some customers will look to pair both solar generation and energy storage into their charging scheme. There are these wonderful carports that can actually keep your car cool, gather the solar energy, and store it in a battery, so when you're ready to charge up, it's good to go. Those are kind of niche solutions, not as applicable for some of the larger fleets, because just the logistics of, for example, bringing in a bunch of delivery trucks or bringing in a bunch of school buses into a given charging depot, you need more plug load than those carports can do. But those are great for, you know, residential applications, suburban applications, a little more challenging in our urban environment of New York City.
So when we think about renewables and we think about distributed generation, what are some of the activities that Con Ed is taking on in terms of sort of preparing us for what we see as this sort of, you know, increase, you know, particularly in terms of sort of like your wires and what's happening kind of underground, if you will?
Sure. A lot of our infrastructure is geared to, it was originally designed to be a one-way grid, as you heard from the previous speaker, that some of the one-way power flows, the protection devices that were built to make sure that we didn't have backfeed onto our high-tension primary feeders. Basically, we have these things called network protectors, which are big circuit breakers. And if they detect reverse power flow, they'll trip open because that was a sign of a problem upstream. The challenge we have is with customers putting in, whether it's photovoltaics, batteries, fuel cells, we now want to encourage that reverse power flow. So we're proactively going through and reprogramming our network protectors to enable that. So that's a proactive, preemptive step that we're doing to increase what's called hosting capacity, which is the ability to interconnect DER locally into the area. Putting it locally is really important because it both gives customers the tools at their disposal to control their own energy cost, and it also avoids the transmission losses. If we can deliver and share that power within a community, we don't have to import it over longer distances, which itself uses power in those transmission losses to get it into New York City.
So one of the programs that that Con Ed runs is this Non-Wires Alternatives program, and that sort of feels similar to what you're talking about here in terms of offsetting load with generation or reduction of energy use within an area. Do you want to talk a little bit about?
Sure. Yeah, that's kind of one of our marquee programs. It originally started as our Brooklyn Queens Demand Management Program, where we were looking to defer the need for $1 billion, yes, $1 billion substation, and really went out to the market and went out to our customers and said, what can you do for us? So it gave us the ability to have a solicitation where we wound up entering into contracts with customers to pay them to install batteries, fuel cells, solar, a variety of different technologies, and operate that at our peak conditions to avoid having to put in those transformers and that type of a substation. By getting to that sort of distributed network, not only are we giving customers the ability to control their own destiny and reduce their power consumption by self-supplying their own energy needs, we come up with a cheaper solution for all of our customers. So that's kind of the one of the lenses of what we think of as the smart grid. It's not just making the grid smarter so it can sort of sectionalize and be more resilient for customers, but it's using it smarter by enabling customers to be part of the solution instead of just the one-way recipient of the power flow. In order to enable that, we've had to challenge our engineers. So when they come up with a need in our planning process, to say, we can't just assume we're going to be building a traditional solution. Let's think of how to use distributed resources. So we'll map the area impacted, look at what we've done historically in terms of energy efficiency and similar non-wires programs, and see how much more do we think we can encourage our customers to help us. And if we get the right criteria, we'll do these non-wires solicitations.
It's a great example of partnering with your customers and utilizing, different technologies to generate power or find efficiencies. So, congratulations on developing that and the successes you've had with that program. Unfortunately, this is all the time we have today. I hope I can bring you back again on a future show, and thank you for sharing your expertise and Con Ed's work with us.
Thanks for having me here.
You can find out about career options on the Department of Energy website and explore the many courses, undergraduate and graduate degrees that CUNY has to offer in these fields at cuny.edu. Please keep the conversation going and follow CUNY TV or send us a message on Instagram or Facebook. Thank you for watching, and tune in next month when we will discuss energy storage.